Assalamualaikum warahmatullahi wabarakatuh. In this slide, me, Wan Fatin Amira binti Wan Muhammad Tamizi, and my other teammates, Siti Sofia binti Azmi, Amira Safia binti Muhammad Naziri, Nur Aliatul Izzah binti Yahya, Nur Farah Atira binti Mustafa, and Iman Nur Karirah binti Nur Hazmi, will be presenting about vectoring plane. For contents, first, executive summary, second, introduction, third, purpose of study, fourth, methodology, fifth, result and discussion, and sixth, conclusion.
First of all, we are going to discuss about the executive summary of vectoring plane. In a nutshell, vectoring by air traffic controllers is able to resolve conflicts, as the goal of vectoring is to have the aircraft achieve and maintain the desired track. The formula of angle between two vectors is implemented to find the angle needed to change the direction of those planes. The calculation is performed to determine whether controller intervention would be necessary. After vectoring, the controller must instruct the pilot to resume navigation, giving them the aircraft's position if required. The problem that the air traffic controllers team encountered was to find an accurate angle in order to avoid collision among planes and how to determine the direction of the turn of those planes. Last but not least, there are some cautions that should be exercised by air traffic controllers when vectoring, such as wind direction, airplane speeds, limitations, and also misunderstandings to avoid unnecessary accidents.
Now, moving on to the introduction. An aircraft is a vehicle that is able to fly by gaining support from the air. It counters the force of gravity by using either static lift or by using the dynamic lift of an airfoil, or in a few cases, the downward thrust from jet engines. Aircraft vectoring is a navigation service provided to aircraft by air control. The controller decides on a particular airfield traffic pattern for the aircraft to fly, composed of specific legs or vectors. The aircraft then follows this pattern when the controller instructs the pilot to fly specific headings at appropriate times. Vectoring is used to separate aircraft by a specified distance, to aid the navigation of flights, and to guidance aircraft to a position from which they can continue their final approach to land under the guidance of an approach procedure published by the Federal Aviation Administration (FAA). Moving on to the purpose of study.
Purpose of study is to manage the use of vectoring by air traffic controllers to manage the traffic flow and resolve conflicts.
For methodology, the following assumption was made in this analysis. There are two airplanes flying from opposite direction that are going to collide into each other. The system of equations for the model was formulated as follows. At line A, vector for airplane A is 100, negative 200, and 300. At line B, vector for airplane B is 300, negative 400, 200. We then use the angle between two vectors to solve the system of equations and by also including the dot products. The vectors represent the flow of the direction between the AirAsia and Malaysia Airlines plane.
The following diagram shows the directions of the AirAsia plane and Malaysia Airlines plane. Assume that they are going to collide into each other at point W, so find the angle needed by Malaysia Airlines plane to avoid the collision from happening. So here are the solutions for the equation. So firstly, for each direction, the altitude can be shown by this vector, which is A. The vector for A is 100, negative 200, and 300, while vector for B is 300, negative 400, and 200. Next, since both A and B are non-zero vectors, the dot product between A and B, whereas A dot B is a real number defined as 100 multiplied by 300 plus negative 200 multiplied by negative 400 and plus 300 multiplied by 200, which is equal to 170,000. We then can find magnitude or length of vector A and B represented by the symbol magnitude A and magnitude B, and it can be calculated by using the following formula. Theta, which will represent the angle needed by the airplane B to change its direction, can be found between A and B. Then A dot B equal to magnitude A multiplied by magnitude B and multiplied by cos theta. And the final answer will be theta equal to 32.47 degree, and that will be the angle needed by the airplane to change its direction in order to avoid the collision.
Factoring the requesting aircraft, which is the Malaysia Airlines plane. If a pilot makes a request, usually to climb, and accommodating this request would result in sufficient separation with another aircraft, then the general choice is to vector the requester. This is usually done for safety reasons. The controller then will decide that the Malaysia Airlines plane will lift up to 32.7 degree, placing it on a parallel track and finally instructing to it to resume navigation. So for the conclusion, Asia plane and Malaysia Airlines plane will not collide since Malaysia Airlines plane will change direction before both airplanes meet. Thus, no collision between airplanes will occur. Since there is no path in the air, the navigation system helps airplanes to change direction using vectors. Factoring the request for path changing is the way to help airplanes move on air without colliding with each other. It also helps the traffic flow and resolve conflicts for aircraft. To conclude, factoring helps aircraft to move freely as it gives a direct and precise direction to aircraft.